Hey guys, so in this video here, I'm going to be talking to you guys about parent functions and how you can look at functions and determine what type of parent function it goes along with. So before I start with the warm-up here, I'm going to actually scroll down to definitions and talk to you about the different types of functions that you might encounter. So the most basic type is if you have a function and it equals just some number. So I mean you have some sort of equation or function that's like y equals, I don't know, 3. So in this case, if you were to draw out the function in a coordinate system, you would go to 3, or y equals 3, and you would graph, and you would have like a horizontal line. This is what we call a constant function. Notice how it's a flat line. And so if you have an equation that just equals a constant, you typically have a horizontal line or a flat line because there's really no slope here. But if you have f of x equals x, or x to the first power, if you have this case, then this is referred to as a linear function because it creates a function that has that line that we typically see, usually with a slope, right? So this is usually associated to y equals mx plus b. Notice how this x here is to the first power, and you usually have a slope. So in this case, the slope would have been 1. And you usually have a y-intercept. Now this one doesn't have a y-intercept, so we assume that it's going to be at 0. If you have x squared, most of you guys are more familiar with this one. You have a quadratic. And so you're going to have a function that looks like a u, like that. If you have something like this, which is x cubed, then you have a cubic function. And so it looks kind of like, someone once told me that it looks kind of like a paperclip unraveled or a lightning bulb. So I'm going to go with that, but it looks kind of like that. Basically, the positive side of x is pointing upwards. The negative side of x points downwards. This one here is the absolute value equation. So absolute values typically have that V-shaped curve. So it looks like this, a V-shaped curve. And then when you have the square root function, and in this case, I'm going to assume that this is a positive square root because there's no negative sign or plus and minus in front. So if you have a square root function, it looks kind of like a shooting star. So it starts usually at the origin and it shoots out like that. So those are all your different types of parent functions. Now, what will happen in this chapter is you're going to learn all the different shifts that associate with each parent function. So now let's go back to the warm-up problem and talk about the different basic shifts that you've learned in Algebra 2. So it doesn't matter what type of parent function it's associated with, the shifts are relatively the same when it comes to any type of parent function. Typically, when you have an equation, you have a parentheses or square root, but in the inside of the parentheses, usually you have an x, and if it says like a minus sign inside, let's put h, and sometimes you have something that's helping it shift up and down, so I'll just put a plus k here. And sometimes you have a slope, so I'll put it like, actually let's put an a here. So if you have an equation like this, typically your a, or the number in front of x, you can use as your slope, but you're going to use it very diligently, meaning when you use a slope, you're always going to make sure that the a, or the slope, is over 1. And then for the shift on the inside, if you have a minus h, on the inside, minus always means right shift, and positive always means left shift. So in the inside of parentheses, or an inside of an absolute value or square root, anytime it's a minus sign, it's shifting right. Anytime it's a positive sign, it's shifting left. This outside piece, if you have a plus sign, it's moving up, and minus sign moving down. So those are the basic shifts. And we're going to utilize this type of shifting to help us here to graph. So notice like it's asking us for the parent function and to sketch a quick graph. So one of the things when I noticed, part A is that this x is to the first power. Because I immediately noticed that, I know that this guy is linear. And if it's linear, to graph it, I need the slope and I need the y-intercept. So in this case, the slope here is, I think 1. So this is going to be 1 over 1. Remember how I said the slope is typically you write it over 1. And so for the y-intercept, I have it at -3. So that means I have to go down to -3. And now I'm going to use the slope, go up 1 over 1, plot, and then just graph my equation. There we go. All right, let's try another one here. So this is x squared. So this is a quadratic, or it's connected to a quadratic function. And so this one is a little bit strange because you have a shift here. So this is not just that U-shaped, it's been shifted up. So this guy means up 3. So if I go up 3, I'd be here. And now you can also use this to graph, but you can use the slope or the number in front of x squared. So the slope here is 1 over 1. Basically, take the x squared because it's the highest power, use the number in front of it, the coefficient in front of it. So you would have 1 over 1. So you go up 1 over 1, plot, and then graph your curve. And quadratics are symmetrical. So if you went up 1 over 1, you're going to go up 1 over 1 on the other side, plot, and graph. And there you have your parabola. Our next one here is an absolute value function. So our absolute value function is our parent function. So I already know that this is going to be a V-shaped curve. So what I need to notice is what is this shift saying. So notice that this is inside the parentheses or inside the absolute value. So this is saying left because it's a plus sign. So left 2. So it'll be right here. So instead of at the origin, it's going left 2. Now I'm going to draw my V. And it looks like the slope here is also 1. So 1 over 1. So I'm going to go from this point up 1 over 1 and draw my V. And the absolute value functions are also symmetrical. So I have to go up 1 over 1 to the left and then draw my V. There we go. All right. So our last one here is a square root function. So I'm going to just write square root. And so in this case, I do also have an inside shift. So this says -2. So if it's on the inside of the root, this is going to be right 2. So from the origin, I'm going to shift to the right, draw me a point there, and then looks like my slope here is also 1. So I'm going to do 1 over 1, plot, and then I'm going to draw my one-sided curve. Because I know that square root functions, if I look down at its parent function, looks like this right here. Only this guy has been shifted right 2. So that's why this has been moved slightly to the right. But it still has that one-sided curve shape. Okay, so hopefully this gives you a better idea of different types of parent functions that you might see and the basic types of shift. We're going to get into more details about different shifts in the next video, so stay tuned for that.